Alright guys, so today we're going to be using quadratics to solve a real life problem. So kind of see what we can use this math stuff we've been learning for. So we have, it's going to be, they're like multi-step problems really. So what we're going to do is we're going to complete this first half of your worksheet here. And then after that, the rest of the class you guys are going to work on the back. So instead of doing like little pieces, like a little problem, and you guys get to practice like one big one, and you guys get to work on it for the rest of the class. Okay. Yeah. That. This week on my class. All right. Uh-oh. Is he gonna talk over there too? Because literally, Henry, I literally have nowhere else to put you, Henry. I was hoping you didn't have friends over here too. Okay. All right. Tempting. Let's see here. So here we go. A baseball is hit from an initial height of 1 meter. After going 15 meters horizontally, it reaches a maximum height of 10 meters vertically. So what you guys need to do is you need to turn this crazy, ugly sentence into a picture in your head. Okay? So can you guys imagine a baseball, right? It's hit from a meter. Can you guys visualize that? About this high? About a meter. And then it says after going 15 meters horizontally, it reaches a maximum height of 10. So by the time it's 15 meters away from you, the height is 10. Does that make sense? Can you guys kind of visualize that? So we're going to draw that picture. That's what part 1 says here. And what we're going to do is we're going to let x represent the horizontal distance, and we're going to let y represent the vertical distance. So let's go ahead and fill out part A on your worksheet that I've given you there. So we're going to make a graph. The y-axis is going to represent the height of the ball, and we're going to say that the x-axis represents the distance of the ball. Okay? And how high up was it when it was first hit?
1 meter.
So I'm going to put a dot right here at 1. That's the starting height. So it starts there. And then it said after it traveled how far away from me?
15.
So I'm going to go out to 15. After it was that far away from me, how high up was it?
15. 10. Sorry.
10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by the time it was over here, it was this high. And you guys can imagine, what does this shape look like when you hit or throw something? What does it do? Does it just go straight up and keep going forever? It makes a parabola, doesn't it? And we're talking about parabolas. So we're going to draw a parabola that kind of fits this story problem here. So there it goes. And it says that's the highest point.
That's way more than that.
Now on a parabola, what do we call the highest part? The vertex, or the max, right? Either one of those work. And so from here, it's going to start coming back down, right? And then eventually, it's going to land on the ground.
That's the same spot, right? Lower.
What do you mean at the same spot?
Because like I would start at 1 meter.
Oh, no, it'll be on the ground then, right? So that's the first thing you guys want to do is you're going to want to turn the words into a picture, okay? Now we're going to turn that into an equation. So I think that, let me see what the first thing says there. Yeah, part B. So part B, everybody take a look at part B. My part B is different than yours, so look at your notes. Do you guys see part B in your notes? It says write an equation, right?
Yeah.
Okay, so we're going to turn this into an equation. Okay, so let's get out of there for a second. This is what an equation of and you guys should start writing this with me here. This is what the equation of a quadratic looks like, right?
Is that what's on this board? No.
No, no, that's not your guys. That's
I looked at that earlier and I was like, I'm gonna spill it. Go ahead.
no, that's not your guys's. That's, you can ignore that. Okay, what does the H and the K represent?
The length.
Now on our picture, we know our vertex, don't we? What's the vertex of our picture? It's the X is 15. What's the Y? 10. Okay. Now, here's the thing. They also gave us another point. What was the other point that they gave us? That's right. They gave us the 0. Well, they gave us the 1, right? Now, is that 1, is that a Y value or an X?
The Y.
It's a Y value. So what's the X value? Look at your graph. It's a 0. So here's the thing. They gave us a vertex, and they gave us another point. Yeah.
Is the other point the A?
No, but it's going to help us find the A. So I'm glad you brought that up. Because what we really need 3 things to have an equation. We need the H, we need the K, and we need the A. So he realized that. He said, okay, I know we need the A, but we don't have it. This other point is going to help us get it, and I'll show you how.
Question. See how right there it says that that's a vertex?
Yeah,
Can we also write that either our max or minimum?
you could. That's fine. Yeah.
Or you know, you do expression x equals x2 or x1 y2.
No. No. But that's not a bad thing because it's kind of like a slope, right?
Yeah.
But it's not. Remember, quadratics don't have a slope. They constantly change, so we can't really do that here. Okay. So here's the question, guys. For this part, you want to find your vertex, and then you need to find your A, and the way you do is with this point. So I'll show you. Check this out. This is, let's label these. This is a what value?
X.
And what's this? We're going to plug these things in where they go. So what's the Y value here? 1. We don't know the A yet, right? What's the X value?
15.
Well, yes and no, but my X value I want to use here is 0. This is a special X value, and what letter do we call it?
The H.
That's our H and our K, right? So it's 0 minus, what's my H? And what's my K? 10. So here's what we're going to do.
You forgot. Oh, wait, I'm sorry.
Go ahead.
Oh, no, because I thought you forgot the square.
Okay. So we're going to solve for A now. Okay? They are. They're going to be awkward numbers. So here we go. This one's going to be A times 225. 0 take away 15 is negative 15. And negative 15 squared is that. Now I want to solve for A, so what would I do next, you guys?
Multiply. Oh, 10.
Minus the 10 over. So that gives me negative 9. Now what?
Is it
Divide.
Yeah.
And now we're going to have you guys get your phones out. And I want you guys to do negative 9 divided by 225. And we'll round it to, let's say, the hundredths place. Let's go to two numbers after the decimal. So when somebody has it, raise your hand and I'll ask you what you got. What would you get, John?
I'm going to but I got
What'd you get?
I haven't rounded it.
Okay, what'd you get?
I got negative 0.04.
0.04? Okay, let's see if anybody, do you guys agree?
I got negative.
Okay, good. So let's write this down now. That means A equals negative 0.04. Okay? We're almost there. Here we go. Y is equal to A. What's my A value?
Negative.
Times X minus H. What's my H?
Shoot. 15.
And my K.
10.
This equation is the equation of that parabola. Okay? So that was a long process, so I'll review it with you. Okay? Yeah, sure. So let's review. What did we do first? First of all, guys, we drew a graph. I put my starting height. I found my vertex and I sketched the graph, right? That was the first thing I did, because I'm about ready to let you guys practice one like this. After that, I needed to find the equation, okay? So to find the equation, the first thing I did is I found out from my graph what my vertex was, and that goes where the h and the k are at. Then I found out the other point they gave me, the starting point. For me, it was 0, 1. For you, it might be something different. But for me, it was 0, 1. So I plugged in 1 for the y and 0 for the x. And after that, what did we do? After we plugged them in, we
worked out what we
yeah, so big picture, we were trying to find A, right? Yeah. After we find A, we put in 3 things. You plug in your A, your H, and your K. Okay? So you guys are going to do that now. So what I want you guys to do is take your notes, flip it over, and find student practice 1. And then I want you guys to do part A and B. I want you to draw the graph and then write your equation. Okay? And I'll kind of walk you guys through it verbally as you go, but it's your guys' thing. So go ahead and get.
Yeah, you did. Okay, so we're supposed to subtract the other side, which would give you -6 on the other side.
Yeah. I just didn't show my work, but yeah, I said -8 divided by 16, and then you get that. So I just said it. I didn't write it. Being lazy. Wasn't wrong, I was lazy. All right. So here's our graph. There's our A, but we're not done because we actually want to write our equation. So what's our equation?
Y equals 0.38 x minus 4 squared plus 3.
This is what we should have for part B. So box that on part B.
0.38.
You could call it 0.3. Yeah, that's fine. -3.8 would be fine. Okay? Now, let's talk about what we just found. We're just following steps here, right? And it's like, okay, that's nice. I mean, you guys know what this picture means, right? That's like the path of the ball. But what the heck is this? Well, what we have is an equation that tells us something. What does x represent on this problem, you guys? The distance, right? What does y represent? So I've got an equation now that for any, like for instance, if I were to tell you the distance is 2, when the ball is 2 feet away from me, I could plug that in and figure out the height. So I've got an equation now that will help me find one variable so long as I know the other. So if I know the distance, I can plug in something for x and find the height. Or if I know the height, I can plug a number in for y and I can solve for the distance. Okay? And that's what we're going to do next, is we're going to use this equation to start solving some problems about this story problem. Okay? So let's go ahead and jump back to the teacher example now, please. So let's go back up here, flip your paper back over, and I'm going to need a little help here. I think my equation was -0.04 x minus
Squares plus 10.
it. Do we agree with that?
Yeah.
Okay. So let's go ahead and read part C now. Okay, we're going to do part C and D now. So part A and B was just all about taking a situation and turning it into a math expression. Part C and D now is going to be, how do we use this math expression to actually solve some problems now? So part C says, use your equation to find the height. What am I finding? We're finding height. That's correct. That's great. Let's label that. Find the height. That means find the y. I'm really glad you said that. When the ball has traveled 20 meters horizontally, what's that?
X.
That's x. So I'm going to plug what number in?
X.
What number?
20.
I'm going to plug 20 in for x, and I'm going to solve for y. Okay? So you have to know what your numbers mean. So what they did was good. How did you guys know this was a y value? Because I told you earlier height is y. And horizontal distance is x. So in this case, I know x is 20, and I want to find y. So you guys ready? Here we go. 0.04. I'm going to plug in 20 for the x. And I'm going to solve for y. Now you got to follow your order of operations here, guys. What do we do first? Okay, what's 20 minus 15? What comes after parentheses? Exponents. What's 5 squared? Good. What comes after exponents? Okay, I need help for this one, so get out your cell phones. What is negative 0.04 times 25? It's negative 1? Nice. Don't expect it to turn out that nice all the time. They're usually going to be weird, funky decimal numbers, and that's okay. And so we get y equals 9, right? And what does that mean? The height. So once that ball has gone 20 meters away from me, it should be at a height of 9 meters. That's it. But the trick, yeah, you're just plugging stuff in. But here's the trick, though. You have to know where it goes. Does it go in for an x, or does it go in for a y? And that's all based on whether you know that y is height and x is horizontal distance. If you know that, then you're pretty much home free. Okay?
So if for example, we need to find how that's what
The distance?
Yeah, if we had to find the distance and we only need the height, it would be the other way. We'd plug in that number for y, so it would be that number equal.
Exactly. So let's do one like that. That's our next one. Let's go ahead and take a look at part D. So everybody scroll down to part D there on your notes. Well, I guess I will scroll. You just need to move your eyes downwards. Okay. So read the question. Use your equation to find horizontal distance. What am I finding? Horizontal distance. And what letter is that? Find horizontal distance. So we're going to find x this time, not y. We're going to find the horizontal distance that the ball has traveled by the time that it lands where? On the ground. Now that means we know something. If a ball is on the ground, we know its height. What's its height?
0.
That means y equals 0. So you might want to write that, because that's not obvious. But whenever I ask you when does it land on the ground, I'm really telling you a fact. I'm telling you the height is 0, and you're going to use that to find the distance that it traveled to land on the ground. So here's my equation. 15, right?
Yes, sir.
And what number do I know?
Y.
I know the y is
0.
So I'm going to plug 0 in for y.
Solve it like normal?
And now we just solve it. But now the way we solve this is different than the last problem, but we've done this before as well. So yeah, shake it off. Shake off the last problem. Get that out of your head because this is different. Now let's look at this fresh. How do we solve for x?
Subtract 8.
You subtract 8 first. Good. Hello. Now what do you do?
Now you just solve.
Easier said than done, sir.
Is it plus? Isn't it 10? Yeah, I thought it was 10.
Oh, did I put the wrong number?
Yeah.
Sorry. We got to back up, guys. This was 10.
Oh.
Sorry about that. I am recording. The world will see my error. All right. Now what? You guys remember?
We divide.
We do divide. The negative 0.04. Phones out, please. What's 10 divided by 0.04? I want to say 400, but I don't know.
Negative 250.
I was close. 250, 400, same thing. 250?
A negative and a negative cancel out.
Yes.
I thought it was just
No, sir. Now what?
No, about the parentheses.
Oh, square root it.
Square root it. And what special thing happens when you square root?
Oh, cancels out the.
That's true. But something else special happens. Plus and minus.
Oh, that is.
Can you guys do that on your phones for me? Just find the square root of 250. We're not going to break it down like we did before. Just actually do it on your calculator. Hey, Bailey. Hey. Yeah. Yeah. You want me to send her to you? Okay, sure. Paris, give a phone call. I think it's the president. They want to know what we should do about North Korea. That's my best Trump impression. Couldn't do it. All right. So let's continue here. So what was the square root of 250? 15 what? 0.8. Okay, thank you. I didn't turn my recording off. 15.8 equals what? X minus 15? Now I think for our word problem ones, you guys, we can just ignore the negative, okay? Because what you're going to get basically is you're going to get a big number and you're going to get a small number. And we just want the bigger one, so we'll just keep the positive. So what do I do now? Add 15, and we get 30.8. So that means by the time that ball lands on the ground, how far away from it?
30.8 yards.
It'll be about 30.8 meters. Okay? So those are two different things. So if you plug in X, that's one way. If you plug in Y, you solve it a different way. Okay? So what I'd like you guys to do now is go to your student practice on the back of your paper there. And I want you guys to do C and D. Now remember though, you're using a different equation than me. You're using the last equation that we had. What was that? What did you guys have? It was
y equals negative 0.375 parentheses x minus 4 plus 8.
Don't forget the square.
Oh, yeah, my bad.
Okay, yeah, so there's your guys' equation. So I want you guys to do part C and part D. And that's it. So go ahead.